Hey guys, welcome back to my YouTube channel. So I hope you guys are doing great. So let's see what the problem is today. The problem is maximum profit in job scheduling. So I will explain the approach and how I approach this problem and all the thinking process which was there. So let's see what the problem is first. So we have n jobs where every job is scheduled to be done from start time to end time, obtaining a profit of this much. Okay, so we are given a start time and the end time of a job and the profit associated with that job. Okay, that is, so this is my first job, this is my second job, third job, and so on. This is the start time, this is the end time of the job, and this is the profit which I get by running this job. So this job starts at 1, it completes at 3. Okay, its end time is 3 and the profit I get is 20. Similarly, the second job, it starts at 2, then it stops at 5. Okay, and I get a profit of 20. So you are given the start time, end time, and profit arrays. Okay, so we are given different arrays of the job. So this is the start time of the job, end time, and the profit. Then the start time, so this is the start time, then and then the end time, that is 4, and then the profit. Okay, return the maximum profit you can take such that there are no jobs, two jobs in the subset with the overlapping time range. Okay, so we have to return the maximum profit which we can get by running the jobs such that there are no two jobs which are running together at the same time. Okay, there cannot be two jobs which will run at the same time. This we have to make sure. If you choose a job that ends at time x, you will be able to start another job that starts at time x. Okay, what does this mean? So let's say there is a job 1 which starts at x1 and it completes at y1. So let's say there is another job j2 which starts at y1 and it completes at z1. So I can take this job, and after that, once this is completed, I can take this another job also. So what does that mean? Basically the end time and the start time of the jobs can if they are same, we can start those jobs. Okay, so I hope you understood the problem. Let's see the first test case and evaluate it. Okay, let me just quickly erase this. Okay, so first of all, see guys, when I saw this problem now, first of all I thought of using greedy approach. Okay, why greedy approach I thought? Because see, we have to get maximum profit, right? We have to get maximum profit. We have to get maximum profit. So what I thought was ki I will just sort these jobs with the profit that is in the descending order, that is the maximum to minimum. Okay, maximum to minimum. So let's say 60, this is 60. Okay, so first of all, let's say this is the profit, right? So first of all I will take this job because it has the maximum profit. Then accordingly on the start and end time I will choose other jobs. But this approach is not obviously correct. There are many reasons to that. Okay, first reason is that it doesn't necessarily mean that if you're taking the first job initially it will give you the maximum profit. Okay, it doesn't ensure that. Why it doesn't ensure? Because let's say you are taking 100 here, but the time gap is such that you cannot take any more, no more new job after this. The time constraint is such that. So what if I do not take this and I take rest of the jobs, it makes more profit, right? That could be a case. So the greedy approach wasn't best for this problem. Even if you see other test cases also, right? If you go with a greedy approach, you won't be able to get the correct answer, especially in this test case. See, in this test case, the start time is 1111 and the end time is different. So all the three jobs are starting at the same time and their end times are different and their profits are different. Okay, so the greedy approach wasn't good for this problem. So that's why I thought of thinking something else. Okay, so let me just quickly erase this. Now see how we can think of the another approach. Okay, let's see. This is 60. So see, we have to find the maximum profit. Okay, we have to find the maximum profit. First of all, in mostly these kind of problems, right, the first thing we should do is to sort based on the time. Sort based on time. Why sort on based on time? Because see guys, basic thing, right? If a job is at 1, starting from 1, and a job which is starting at 3, if they are written something like this, so here let's say initially in the code you have something like this. Oh sorry, 3 is job, is 3 comma 5 comma 10, something like this is written, and then the second array is the something like this, 1 comma 7 comma 20. So no sense obviously in starting the iteration from this first, right? Obviously 1 will come first. It's time guys, right? It's time. Okay, so it's basically straightforward to sort the array first based on the time, because obviously one instance will come earlier, right, than 3. One will obviously come earlier, so we have to anyway pick that job. Okay, so first the thing is, when we get these problems, these kind of problems, first sort it. First sort on the basis of time. So I will just sort this array. Already this array is sorted because 1 2 3 4 and 6, it's already sorted. Okay, but if you take this test case, right, like one, take some other test case like this one, 1 2 3, this is also sorted. 1 2 3 3 also. Okay, basically if it's not sorted, you have to just sort it. Okay, so first step is to sort the array. So you can just simply make a make a 1D array, basically make a 2D array, something like this. So this will be start time, this will be the end time, and the profit. You are given different arrays. Okay, so you can just make it into a single array, something like this. This will be a 2D array with rows. These are the rows, and 3 columns always. 3 columns. This is the start, this is the end time, and the profit. Okay, now let's see how we can proceed further. So guys, see, I have a choice. I have a choice. If I take this job or I skip it. I take this job, I skip it. I take this job, I skip it. Because it's my choice. If I want to take this job, if I want to take it, I will consider its profit, which I'll get. If I do not want to take it, I won't consider its profit. Alright. Simple thing. So whenever choice comes, I've already told many times, let's think of recursion. Because recursion is what? Choosing, right? Take this, skip it, take this, or skip it, like that. So, alright, let's see how we can apply recursion here. Let's just simply erase this. Here I will write the steps. So first of all, what we did was sort. Okay. So, see. Now, I have a choice. I have a choice to either take this job, so take it, or I have a choice to skip it. Skip it. Alright, let's see first the take it scenario. If I take it, alright, if I take this job, I will get a profit of 20 plus whatever profit I get from the rest of the jobs. So from the rest of the jobs, those are these. So if I just quickly um I think fine. I think basically so I'll just quickly write it only. Not able to find the option. So we have 2 5 20, then we have 3 10 100. Okay, and then we have 3 10 100. Then we have 4 6 70, 6 9 60. Okay, so now I have just this recursion will go on. Okay, now I have again choice for this job. Shall I take this job? Shall I do not take it? If I take it, okay, if I take it, I'll get a profit of 20 plus the rest of the jobs. That are those are these 3 10 100 4 6 70 6 9 60. Okay, similarly, I can if I do not if I take this 310, I'm just quickly making the recursion tree. You, if you know it, you can skip to the you skip to further. So take it or skip it. So again, if we take it 100. So guys, now do you think that we are missing something? Do you think we are missing something? I'm telling you to take it every time. But do you think we are missing something? I am saying that once, see guys, very important thing. Now see where we are making mistake. This is how we learn, okay? So first I told you to take this job. So the job will start from 1 and it will end at 3. I take it. Then I told you to take this job 2 5 10. That is, it starts at 2 and it ends at 5. But can we take this job? No, we cannot take it. Why? Because they've already told in the question that you cannot have two jobs running parallelly. In this time, if you take this job, your two jobs, that is the first job and the second job, will be running parallel. See, these are parallel jobs. So you cannot take it. This case is already not possible. For this, if you take it, if you take this first job, the only option for you to take is not this one. You have to take this, the next one. Okay. So similarly, you have to check every time. So the thing is, let's say you have this 1 3 and 20, and you have two options, either to take it or to skip it. Okay, let's say you take it, so you'll get a profit of 20 plus. Now the option is the further options, let's say 3 and what was that, 2 and 5 and so on. Okay, so now you have, if you have taken it and now you have option to take it, take again. When you're taking, right, you need to check that whatever was the previous end time, let's say the previous end time. So see, for this job, when you have taken it, the previous end time is now 3. So this is 3. So if you take another job, it should start after or at the same time of 3, right? Because here it's mentioned that if a job you choose, it should be start at the same time the previous job has ended. It can start, or it obviously it can start after that also. So uh, you have to have a previous end time variable, and when you are choosing a job, you have to compare that whether the start time of this job is greater than equal to the previous end time. Then only you can take that job. If this is true, that is, if the start time, that's 2, is greater than equal to the previous end time, which was 3, here it is not, so you cannot take this job. You can take, you will have to check for the other job, like it's 3 10 100. So if you see here, if you take uh, 3 10 100, okay, if you take 3 10 100, now start time is 3, which is greater than equal to the end time, previous end time, which is also 3. So it's equal, hence this condition is true, so you can take this job. You cannot take this job. So if this is true, then only you can take it. Otherwise you have only option to skip it, right? So I hope you got this thing. So basically, I will not draw the entire recursion tree, you can draw itself. So basically, when we are at x job, we will have a function which will be storing, in that function we will be having the current index which we are at, the previous end time, and previous end time. Basically these two things. Okay, so now when we have a choice to take this job X, if we take it, we will add its profit whatever is associated with his X job, plus we will make a recursive call, okay, to the next index, so that we can take. But if we, before taking it, yeah, we have to have a condition here that if the start time of this job is greater than equal to the previous end time which was for the previous job, then only we can take this job. And if we want to skip it, then we will not consider its profit, and we will just simply make a recursive call to the next index. Next index meaning next job. Okay, so I hope you understood this recursive approach. Let's see it in the code, how we have written the code for this. So see, I'm just quickly commenting this. Okay, so basically I've done memoization also. So if you are not aware of memoization, I will highly recommend first learn what memoization technique is. It's just for optimization for recursive solution. So initially we have taken this jobs array, which is a 2D array, as I told you. We will be making a 2D array, hence we have made it, and we have sorted it based on the start time. After that, we are making a recursive, we are making this recursive function in which we are passing the previous end time. So initially for the first job, previous end time is 1 only. It obviously it starts at 1, so we have given 1 only, and the start index is 0. Okay, first index obviously. Then this is the base condition that if index becomes greater than equal to n, this is for the memoization. If we have already computed the solution, we will simply return it. And then we, if we skip the job, if we skip choose to skip the current job, we will make call to the next index and we will pass the end time. Otherwise, if we choose to take it, we can only choose it if the current, see the current start time, this is idx, the current job, 0 means the start time, is greater than the previous end time, greater than equal to, which was at this condition. Okay, then only we can consider the profit and make the next recursive call. Otherwise, take it as 0, because we won't take it. Take the maximum of skip it and take it, and we will return that, because we want the maximum profit. Whatever profit we'll get from this or this, we'll take maximum of it and we'll return it. So this is your first approach. Okay, now guys, this first approach will work, but it won't work for all the test cases. Why it won't work for the all the test cases? So let's quickly see that. I will basically write the test case again quickly. So we have 1, 2, 3. Sorry, we won't write it like this. I will just write it in the 2D format. So 1 is the start time, end time is 3, and profit is 20. You can just skip this part. 2, 5, 20, 3, 10, 100, 3, 10, 100. Then we have 4, 6, 70, 4, 6, 70, and we have 6, 9, 60, 6, 9, 60. Okay, so guys, see, now the thing is, the earlier solution is correct. However, when we are taking it, and when we are skipping it, both the time we are doing idx plus 1, idx plus 1 for the next job, right? We shouldn't do that. When we are taking it, it means we have taken the current job. Now we know that the next job which will come, its start time should be greater than the end time of this job, right? Or equal to. So why don't we find such index of that job and we pass it there instead of idx plus 1. That is the next job index we find and we pass it. Not every time we do idx plus 1. For example, let's say we have taken this job. Now if I take it, what I will do is I will do idx plus 1 and now it will come to this, and then we will check that whether it's possible or not and all that. So anyway we will make one recursive call in order to reach to here. We can avoid this recursive call by directly finding out that whether we can go to that job or not, by finding out the next job basically. So when we are here, this is my array, right? I will find which is the next possible job I can take whose start time is greater than equal to the end time of my current job, right? So the start time of this job is greater than equal, that is it's equal to the end time, so I can take this job. So when I have make a recursive call after this, I will pass the index of this one, that is 0 1 2. I will pass second index. I will not do idx plus 1. Fine. Now guys, if you remember, we have already sort this array, right? We have already sort the array based on the start time. So we have to search, right? Here we have to search the next possible job. Searching can be of two types: linear search or binary search. Since it's already sorted, we can opt for binary search, right? So how we will do a binary search? Let's see that. I will just quickly erase this. Okay. So now let's say I am currently at this job and I have to find the next eligible job index. Next job index. Let's initially give it as n plus 1. Low I will take start. So this is here I have to do the binary search. So this is my indexing. I will do 0 1 0 1 2 3 4. So this is my start. So start will be 1, end will be 4. I will find out mid. Basic binary search, 1 plus 4 by 2, so it will give me 2. I will come here, I will see that can this be a possible job for after this. So we will compare the start time, 3 is greater than equal to the end time 3. Yes, it's equal. So this could be our possible job which we can take. I will update this next job index to be 2, and there might be some other job which is previous to this, right, which satisfies our criteria of the condition end job and all that. So we will update end to be mid minus 1. That is, now we will shift our range. Earlier our range was this much, now our range will be this much. So end will be 2 minus 1, which is 1. Again we will do mid is equal to start plus end by 2, so 1 plus 1 by 2, which is 1. We will find out, okay, we'll come at this 1. We will see whether the start time is greater than equal to the end time. No, it's not, hence this cannot be the possible, and we will just do the we will do start plus 1 by 2. We will we will update the start by mid plus end by 2. So mid is 1, 1 plus 1 by 2 will be 1 plus 1 will be 2. So 2 is greater than equal to 1. So the condition for the while loop is always while start is less than equal to end. Now here its condition is broken. So basically the next job index comes out to be 2. So now for after this we will go to the index 2. So this is how basically we are saving our recursive calls. Okay, we will saving a recursive calls, saving a recursive calls, because here we will go to this or we will go to this if we do idx plus 1. If we do this binary search thing, we will go directly from this to this. So I hope you understood this approach. It's a optimization of the previous approach. Let's see the code. Nothing different. We are basically we are basically uh, here finding out the next job index by doing the binary search. Once we find the next job index, here we will, this is the skip it condition, and here this is the take it condition, and the next job index we will pass to be the one which we have found, and we will return the maximum. So time complexity for this is nlogn basically. I hope you understood the problem and the approach. Space complexity, we are taking this array O of n because basically it's a 2D array, but always columns are 3, so it's O of n only, space complexity, and time is n log n. So I hope you understood the problem and the approach, guys. Code yourself, will better understand, try run. So if you found the video helpful, please like it, subscribe to my channel. I'll see you in the next video. Thank you.